Hi, my name is Srinivas Gogula. So I'm going to present my final project, which is on handwritten text transcription. I'll give a quick introduction on what is handwritten text transcription. So, which is a process of identifying and extracting the handwritten text from scanned images. And if we talk about the use cases, there are several use cases. Some of them are to, some of the examples are to identify the amounts on checks for processing and recognizing the addresses from mails, and also, digitizing the libraries wherein, the manual content or the old images can be, digitized for identifying the trends. And to give a quick summary, so I explored various technologies and techniques to, on how to identify and extract the text from handwritten images. So, but primarily I explored convolutional neural networks and mobile net, and I had to finally implement the solution using mobile net, as it uses very low footprint and less memory as compared to the convolution neural network with convolution layers. So here the project consists of primarily 4 steps. The first one is collecting the data for training the model, pre-processing the data, training the model, and the validation. So the implementation uses TensorFlow 2.7 and using a synthetic word data set. So this model takes images of single words as inputs and outputs the recognized text. So some of the challenges that I encountered are, the memory issues. So most of my time was spent on setting up the, right infrastructure, because my computer didn't had the enough computing power, and it didn't work on Google Colab as well, because Google Colab times out after 20 minutes of reading the data from Google Drive, since I had to have the data set stored in Google Drive. So that was one of the major challenge. And I would say I would recommend at least 4 CPUs with 16 GB RAM for running this code, so that you would expect the quicker training time. And some of the libraries and that I used here are NumPy, CV2, TensorFlow 270, Matplotlib, and Python and Pandas. And I used Python 37.10. I think anything over 3 should do. And that IDE I used is Jupyter Notebook. And you can download the dataset here. I provided the link. That dataset contains 8.9 million images. That's pretty huge. So the compressed size itself is 10 gigabytes that you can see here. This is a compressed file that you download, 10 gigabytes. When you uncompress the file, you would see 36 gigabytes of data. That's pretty big. So the environment that I used here is AWS environment with GPU and 2.7 TensorFlow that comes with it. So if you see here, deep learning AMI GPU with TensorFlow 270. It also came with Python 3. And the instance type, the maximum instance type that I could choose was 4 CPUs, 16 gig RAM. I could not go anything over that because of the limitations in AWS, so I could not get the approval. And the third step is configure the instance. So I choose the default settings. I didn't make any modifications there. And for the storage, I added 200 GB storage. I think 100 GB should be fine as well. Anything over 50 GB, I would say should do. And it is optional to add tags. I didn't add any tags. And for the security group, I added, I opened the proxy to open few ports so that I can launch Jupyter Notebook outside of the AWS instance. So you would see it here. So I opened the port 8880 on HTTPS so that I can launch Jupyter Notebook outside of AWS instance. So the below packages that I installed are Python 3, pip3 to install other libraries, and I installed Jupyter, NumPy, CV2, Matplotlib, and Pandas. And the project source code, I copied it into Google Drive, so it's open, so you can download it from here, Google Drive. And once you download the source code, you can move it into your infrastructure. So here, primarily it's two files. One is handwritten text transcription mobilenet and MNT directory. But if you want to download from the original data set, you need to uncompress the tar file. So that gives you the MNT directory. So either way should work. So the data set I copied in Google Drive is small compared to, it's pretty small. It's only, I think, 20,000 images or 30,000 images. And you would launch Jupyter Notebook by typing Jupyter Notebook. And I'll give the step-by-step instructions to develop handwritten character recognition or handwritten text transcription. So I'll go through the code here. So the first step is to import all the required packages, Keras, TensorFlow, NumPy, and other required libraries. And then I'm setting the duplicate library. Okay, this I had to put this one because of some memory issues or compatibility issues. And the TensorFlow version is 270 that I'm using. And here I defined a function to encode each output word into digits and convert the characters to index. So if you see here, character list at index. And the next step is I defined the path to the dataset directory. So if you see the dataset directory, that's MNT here. So that is where your images are. So if I look at here, ls. So that's where the images are. So, and then I'm defining the parameters for training images and also defining the parameters for validation images. And I'm setting the maximum length of the label to 12. And then I'm scanning the file names and directories using os.scan function. So you see the images are in different directories. And I'm scanning all the directories and filtering only .jpg images. And I'm using all three channels of the images that are needed for MobileNet. And I'm reading the height and width of the image. And if it is less than 32 pixels, then I'm adding padding. And same with the width. If it is less than 128, I add padding. And then normalize each image and compute the maximum length of the text. And I'm splitting 30,000. I'm using 30,000 images for training the model here. I could not go anything over 30,000. I tried 150 images once. It only worked once, and after that, the AWS instance, could not handle anything more than 35,000 images. So I could not go anything beyond that. So out of 30,000 images, 10% I'm using it for validation, and the rest for training the model, which is 90%. And once it reaches 30,000, I'll breaking the loop and padding each output label to maximum text length. And here I'm just checking Python version, but I'm not using 2.7 because I'm using Python 3 kernel, so which uses 3.7.10. And I'm defining MobileNet architecture with LSTM and TENS layer for output. And here you see the input shape, 32, 128, and 3 channels. And here I'm getting the layers up to block 6 and adding max pool layer, convolutional layers, and to make the output compatible with the LSTM layer. So I'm using the squeeze and in a Lambda function. And I'm adding a couple of LSTM layers. One uses the channel units of 128 and reducing, and the next one, and I'm reducing it to 64 in this bidirectional layer. And finally, I'm adding a dense layer for the output. And I'm defining this layer. This would be used for at the testing time. And if you see the summary, the total number of parameters that I'm using for training is just 690,000. Whereas the convolutional neural network without mobile net, it's pretty big. So I'll quickly show you that here in a second. Yeah, you should see it here. Yeah, it's 6.6 million. So whereas with mobile net, it's only 690K, which is just 10%. So that's where I could improve the performance of the model. And then defining the input layer dimensions here. And I'm using CTC loss function and constructing the loss function using lambda. And I'm using the model, I'm defining the model to be used at the training time. And I'm combining the model using Adam optimizer and also defining the CTC loss function. And I'm saving the model here. So if you see the model, the saved model, that model is here. So I'm saving the model, defining the checkpoints and using that for the callback inside the model. And I'm converting the data into NumPy arrays for both the training the data and the validation data. And here I'm using the batch size of 140 epochs for training the model. I tried 100, but I didn't see significant improvement after 30, 40 epochs. So I stick to 40. And you would see, you would see, so it took close to 300 seconds. So it's how much? 5 minutes for each epoch. So, and then I'm plotting the loss. So here, if you see after 30, it's not much improvement, 30, 40 epochs. And then I'm, the next step, I'm predicting the text from the images. So it did decent job in terms of predicting the text from the images. So 10%, which is 3,000 images that you would see and 3,000 text. And then to find out the accuracy, so I used Levenstein so that I can find the distance between the strings, the actual string and the text in the image and the predicted text from the image. So I'm using CTC decoder to get the output, and then using Levenstein distance to measure the distance between two strings. And the average edit distance that I found is 1.88, which I believe is pretty decent given the number of images that I used for training the model, which is just 30,000 images. So that concludes my application details that I developed. And I also added few, the troubleshooting, again, as I said, you get memory errors. If you get memory errors, probably you may want to reduce the data set size. I started with 150,000 images, but my AWS instance could not handle, and I had to reduce it to 30,000. So that's something that you may want to test out. And also, there are other memory related errors that I got, so I had to update some of the libraries to overcome the errors. And the future improvements, I would say, this model can be enhanced to recognize the text for other languages. And also, this particular model only checks one word at a time. So probably I need to enhance it to recognize multiple words at the same time in an image. And here are some of the references, material references that I used for the data set and different types of models and things like that. So you would see it here. And the conclusion is, I would say I could develop this using Python TensorFlow 2.7 and Python machine learning libraries. And also, as I said, the machine learning, the average edit distance between the prediction and the label invalidation is 1.88, which I believe is satisfactory. And also the saved model is pretty small, 8 GB, sorry, 8 MB. So which is quite low compared to the regular model with regular convolutional layers. That concludes my final presentation and detailed demo on handwritten text transcription. Thank you so much for giving me this opportunity to present my final project. Thanks a lot.